I'm Olivier Lafon. I'm professor at the University of Lille, which is located in the north of France, close to the Belgian border. My research field is material science and NMR spectroscopy. So we used this technique to probe the structure of material at atomic level. We try to understand the defect, the surface of the material, and the relationship between the structure and their property. I think NMR is really a powerful technique for the study of material because it's a local characterization technique with atomic resolution. Also, the beauty of this technique is you can access the dynamics, so you can see the motion of the atoms. As I say, NMR can allow you to probe defects, so we can see, for instance, catalytic site on the surface, and this is really important to design more efficient catalysts and, for instance, to convert the carbon dioxide into useful chemicals such as drugs or into polymers. In fact, we can make an analogy between NMR and astronomy. So going to higher field is like having a more powerful telescope. So we are able to distinguish better the local environment of the atom. So to see, or if we want to, it's like a better microscope, we can see in more detail the structure of the matter. We have also more sensitivity. We can see also isotopes which are difficult to detect at lower fields, for instance, to detect sulfur, to detect titanium. This is very important for a wide range of material, including catalysts, but also material for batteries and other type of energy materials. I work mainly on material for energy because I think we face a major challenge with climate change, and we need to develop more efficient technology to produce energy or to convert CO2 into chemical. In a sense, we are lucky. We face major transition, so the industry will completely change in the next 10, 20 years. And as a scientist, I want to contribute to that change. And we use NMR to understand the structure of the material. So with very high field, we want, for instance, to observe a sulfur atom, and sulfide anions are present in many solid electrolytes which are used in batteries. So we think that ultra-high field NMR will be useful to develop all solid-state batteries, because we will understand better how we can modify the electrolyte to improve its conductivity and to improve the performance of the batteries. Yes, so recently we investigated electrolytes used in micro batteries. So they are used, for instance, for medical implant to measure the pressure, for instance, in the eyes for patients who suffer from some disease with too high pressure in the eyes. So the problem is to improve the power, to increase the power of these micro batteries, and for this we need to enhance the conductivity of the solid electrolyte, which is based for the moment on lithium phosphate with also some nitrogen atom in the electrolyte. But the conductivity is lower compared to other electrolytes, and for instance to liquid electrolyte. So we have used NMR to understand the atomic level of this material. It's difficult because they are amorphous, they lack long-range order. So by combining NMR and other technique like XPS and also electrochemical measurement, we were able to understand the relationship between their structure and their conductivity. So we are very happy that 1.2 gigahertz NMR spectrometer was installed in Lille recently. It's one of the first in the world for the study of materials, so it's a chance for our group, for France also as a world country, because we are part of a national infrastructure called Infra-Analytics. And we will use this unique instrument to get new insight into the structure of material, like energy material, like catalyst. So NMR spectroscopy is really the core of my research, because my research is about pushing the frontiers of NMR to get new insight into the structure of materials.